The sun rises over the African plains, revealing a singular, towering silhouette, the giraffe. Its long neck and legs make it an icon of the savanna, a living marvel of evolution. The giraffe's unique form allows it to browse treetops, moving with serene grace above the grasslands. Social and watchful, giraffes transform the landscape, their presence a testament to adaptation. But behind this familiar image lies a story of survival and evolutionary ingenuity. How did the giraffe become nature's tallest marvel? The answer takes us deep into the past. To understand the giraffe is to witness evolution's creativity at its finest. The giraffe's neck is its most striking feature, enabling it to reach food no other land mammal can. But was it only about feeding? Some scientists believe the neck also evolved as a weapon in fierce mating battles. Males swing their necks in dramatic contests. Victory means passing on their genes. This dual-purpose neck is a symbol of both sustenance and strength. Supporting such height required a complete overhaul of the giraffe's body, from a powerful heart to specialized blood vessels. The evolution of the neck is a story of adaptation on every level. The giraffe's anatomy is a masterclass in evolutionary problem-solving. The giraffe's adaptations go far beyond its neck. Its sturdy legs and large hooves support immense weight, while its sloping back balances the long neck. A lightweight skull and a prehensile, sun-resistant tongue make feeding efficient and safe. Height gives giraffes a panoramic view, making them vigilant sentinels of the savanna. Their senses are finely tuned for survival, from sharp eyesight to keen hearing. Every feature, from hooves to eyes, is a product of evolutionary refinement. The giraffe is not just tall, it's a fortress of adaptation. Today's giraffe is the last of a once diverse family, Giraffes. To understand its origins, we journey back millions of years, exploring a world of ancient relatives. Fossils reveal a family tree filled with giants like Civitherium, each with unique adaptations. By piecing together these clues, scientists trace the giraffe's evolutionary path. The fossil record is a detective story, each discovery a new chapter. Why did only one lineage reach such heights? The answers lie in the deep past. Our exploration of the giraffe's evolutionary history begins now. The giraffe is just one branch of the ancient Giraffidae family. Once, this family was rich with diversity. Now, only the giraffe and the elusive okapi remain. Early giraffes were forest dwellers, medium-sized and unremarkable. Over time, some evolved longer necks and legs. Others became powerful browsers like Civitherium. The family tree shows a story of adaptation, extinction, and survival. Studying these extinct relatives reveals the pressures that shaped the modern giraffe. The giraffe's story is one of resilience, a single survivor from a vanished dynasty. Our journey deep into the past begins with a group of animals that are not technically true giraffes, but are their closest known relatives, the Climacosauridae. These creatures, whose name means ladder-horned, roamed the forests of Africa and Asia during the early to middle Miocene, around 20 to 15 million years ago. One of the best-known members of this family is Climacosaurus, a creature that looked more like a deer or an antelope than a giraffe. It was of a modest size, perhaps similar to a modern fallow deer, and it possessed a feature that sets the stage for one of the giraffe's most iconic traits: bony protrusions on its head. These were not true horns or antlers in the way we think of them today. Instead, they were large, branching, skin-covered structures that grew directly from the skull bone, much like the ossicones of a modern giraffe. In Climacosaurus, these structures were particularly impressive, resembling the antlers of a stag, branching out into several points. Scientists believe these antler ossicones were likely used for display or for ritualized combat between males, much like the necking behavior we see in giraffes today. This suggests that from the very beginning of this evolutionary line, competition between males for mating rights was a powerful selective pressure, shaping the anatomy of these ancient animals. The world of the Climacosauridae was very different from the open savannas where we find giraffes now. During the Miocene, Africa was a continent of vast, dense forests and sprawling woodlands. These early ancestors were browsers, feeding on the leaves and fruits of the lower canopy. Their body shape was well suited for moving through this cluttered environment. They had relatively short necks and legs, which would have allowed them to navigate through thick vegetation with ease. They were not reaching for the treetops. They were thriving in the shade below, living a life that was perhaps more similar to that of the modern okapi than the towering giraffe. The discovery of the Climacosaurettids was a crucial step in understanding giraffe evolution because it helped to fill a significant gap in the fossil record. For a long time, the earliest origins of the giraffid family were a mystery. These ladder-horned creatures provided a clear link, a transitional form that showed the early development of the skin-covered ossicones that are a hallmark of the Giraffidae family. They represent a foundational chapter in our story, an early experiment in headgear and social competition that laid the groundwork for the more specialized forms that were to follow as the African environment began its slow, inexorable change from dense forest to open grassland. During the Miocene, early giraffids like Canthumerix emerged from Climacosauretid ancestors, spreading across Africa and Asia. Canthumerix, a deer-like browser, stood at a key evolutionary fork, leading to both giraffes and okapis. Later, Giraffocorix appeared, notable for its 4 ossicones, showcasing the giraffid family's remarkable evolutionary creativity. Of all the extinct relatives of the giraffe, none capture the imagination quite like Civatherium. This was a true giant of the Pliocene and Pleistocene epochs, a colossal giraffid that roamed across Africa and the Indian subcontinent from around 5 million years ago until as recently as 8,000 years ago. The name Civatherium means Shiva's beast, which is honestly a fitting title for such a formidable creature. It was far more robustly built than a modern giraffe, with thick, powerful legs and a massive body. Estimates suggest it may have stood around 2.2 meters tall at the shoulder and weighed over 1,200 kilograms, making it one of the largest ruminants ever to have lived. The most breathtaking feature of Civatherium was its head. It was adorned with a spectacular pair of large, branching ossicones that resembled the palmate antlers of a moose, along with a second, smaller pair of pointed ossicones located above its eyes. This elaborate headgear would have made for a truly imposing sight. Unlike the slender, graceful giraffe, Civatherium was a heavyweight bruiser. Its neck was shorter and much thicker, built to support its massive head and likely used as a powerful weapon in contests between males. It was less of a tower and more of a tank, a giraffid that had evolved for power and strength rather than for extreme height. Civatherium was a grazer and a browser, but its diet was likely different from that of a modern giraffe. Its robust build and shorter neck suggest it fed on lower-level vegetation, such as shrubs, bushes, and perhaps coarse grasses. It lived in more wooded savanna woodland habitats, coexisting with a menagerie of other large mammals, including early elephants, saber-toothed cats, and even early humans. In fact, ancient rock paintings discovered in the Sahara Desert and in India appear to depict Civatherium, suggesting that our own ancestors were familiar with this magnificent beast. It was a prominent member of its ecosystem for millions of years, a true megafaunal giant. The story of Civatherium is a powerful reminder of the diversity that once existed within the giraffe family. It represents a completely different evolutionary strategy. While the ancestors of the modern giraffe were going high, evolving longer necks to reach a specialized food source, the Civatheres were going wide, evolving immense bulk and formidable weaponry. For a very long time, this was an incredibly successful strategy. The eventual extinction of this mighty creature, relatively recently in geological terms, raises fascinating questions about the changing environment and the pressures that ultimately favored the slender, long-necked survivalist over the heavily armored giant. As we have seen, the world of the ancient giraffids was a vibrant and varied one. For millions of years, creatures like the four-horned Giraffocorix, the deer-like Paleotragus, and the colossal Civatherium shared the planet with the ancestors of the modern giraffe. They occupied different habitats, from dense forests to open woodlands, and they showcased a wide range of body plans. This diversity was the hallmark of a successful and thriving family. Yet today, only the giraffe and the okapi remain. This raises a profound and critical question. What happened to all the others? Why did this rich tapestry of species unravel? leaving just 2 survivors behind. The answer, as with most great extinction events, is complex and likely involves a combination of factors. The primary driver of this decline was almost certainly global climate change, starting in the late Miocene and accelerating through the Pliocene and Pleistocene epochs. The Earth's climate began to cool and dry significantly. The vast, lush forests and woodlands that had once covered much of Africa and Eurasia began to shrink, replaced by more open, arid savannas and grasslands. This was a dramatic environmental shift that fundamentally altered the rules of survival for countless species, including the diverse family of giraffes. This climatic shift had a direct impact on the food sources available to these animals. Many giraffes, like the okapi's ancestors and the robust civeteres, were adapted to browsing on the soft leaves and vegetation found in wooded environments. As these habitats disappeared, so did their food supply. They were specialists in a world that was rapidly changing, and they struggled to adapt. The animals that thrived were those that could take advantage of the new opportunities presented by the expanding savannas. This environmental pressure created an evolutionary filter, favoring some traits while penalizing others, and ultimately leading to the extinction of many giraffe lineages. It was in this changing world that the lineage leading to the modern giraffe found its unique advantage. The open savanna was dotted with acacia and combretum trees, plants that often grew tall and were defended by thorns. The gradual elongation of the neck and legs, a trait that had perhaps begun for other reasons, suddenly became a key to unlocking a vast and uncontested food source. While other browsers were struggling with the diminishing woodlands, the proto-giraffes could thrive by reaching high into the canopies of the savanna trees. This specialization, driven by environmental change, is what likely allowed the giraffe's ancestors to survive and flourish, while their many cousins faded into extinction. For years, the classic theory explained the giraffe's long neck as an adaptation for reaching high leaves, outcompeting other herbivores. Charles Darwin proposed that competition for food drove giraffes to evolve ever longer necks. This gave them access to a private pantry of leaves, a crucial advantage. Today, giraffes feed high above the savanna, seemingly proving the theory. But scientists noticed giraffes often feed at lower levels, even when higher leaves are available. So, could there be more to the story than just food? The giraffe's long neck isn't just for reaching leaves, it's a weapon in fierce battles for mates. Bulls swing their massive necks in dramatic contests, and the strongest win the right to mate. Over generations, this sexual selection has shaped the giraffe's iconic form, making the long neck a symbol of strength and success. Evolving a 6-meter neck is no simple feat. The giraffe's entire body has adapted for this height, from a powerful heart that pumps blood up its long neck, to tight skin and specialized legs that handle immense pressure. Even breathing is a challenge, with huge lungs and a long windpipe. Every part of the giraffe is a marvel of evolution, working together for survival. To understand the giraffe's long neck, we turn to allometry, the study of how body parts grow in proportion to body size. In giraffes, the neck grows faster than the rest of the body, a process called positive allometry. Giraffes have just 7 neck vertebrae like humans, but each is greatly elongated. This growth pattern likely began with sexual selection and was later amplified by natural selection for feeding high in the trees. The giraffe's long neck evolved alongside the acacia's defenses in a co-evolutionary arms race. As giraffes reached higher, acacias grew thorns and produced bitter chemicals. Giraffes countered with tough tongues and thick lips, delicately plucking leaves. This ongoing battle shaped both species, driving the giraffe's height and unique adaptations. The giraffe is as much a product of the acacia as of its own ambition. The journey to the giraffe's great height was not a simple, linear path driven by a single cause. It was a complex and multifaceted process, shaped by a convergence of different evolutionary pressures over millions of years. The most satisfying explanation is not to choose between the competing theories, but to weave them together into a unified hypothesis. The story begins not with food, but with sex. In the ancient forests, sexual selection likely favored male giraffes who were slightly larger and had longer, more powerful necks for use in combat. establishing a pattern of positive allometric growth for the neck. Then, the world changed. The climate cooled and dried, and the vast forests gave way to open savannas. This dramatic environmental shift was the critical turning point. Suddenly, the trait that had been favored for fighting, a longer neck, found a new and incredibly valuable purpose. The scattered acacia trees of the new landscape represented an untapped food resource, and the proto-giraffes, with their pre-existing tendency for neck elongation, were perfectly poised to exploit it. Natural selection for feeding then took over as a primary driver, amplifying the allometric trend that sexual selection had already initiated. The neck began its rapid journey skyward. This new feeding strategy then kicked off the co-evolutionary arms race with the acacia trees. As giraffes reached higher, the trees evolved thorns and chemical defenses. In response, the giraffes evolved their tough, prehensile tongues and a nomadic browsing strategy. Each adaptation on one side prompted a counter-adaptation on the other. All the while, the immense physiological challenges of height had to be solved. The heart grew stronger, the circulatory system developed its wonderful net, and the respiratory system expanded. Evolution was working on all fronts simultaneously, modifying the entire organism to support this one specialized and highly successful way of life. Therefore, the giraffe's neck is the spectacular result of a perfect evolutionary storm. It is a product of male-male competition, female choice, climate change, competition for food, and a co-evolutionary battle with its primary food source. No single factor can claim full credit. It is the interplay between all these forces that sculpted this unique animal. The giraffe stands tall on the savanna today, not because of one simple reason, but because a whole series of events and pressures aligned perfectly in its evolutionary history, pushing it ever upward to become the magnificent, towering marvel we see today. The giraffe's daily life revolves around finding enough food to fuel its towering body. Its favorite meal? The acacia tree bristling with thorns. But with thick lips, a long, nimble tongue, and sticky saliva, the giraffe skillfully strips leaves while avoiding the thorns. This unique toolkit lets it thrive in the ever-changing African savanna. Giraffes get most of their water from the fresh leaves they eat, rarely needing to drink from risky waterholes. To get vital minerals, they chew on bones and sometimes eat soil, behaviors called osteophagy and geophagy. These clever adaptations help giraffes thrive in the challenging African landscape. Despite its immense size, the giraffe faces a formidable enemy, the lion. Lions hunt in coordinated prides, using stealth and teamwork to challenge even the tallest giants. But giraffes are not helpless. They defend themselves with powerful kicks that can be deadly. Their height and keen eyesight help them spot danger early, often allowing escape. This ongoing battle is a dramatic dance of survival on the African savanna. Life for a newborn giraffe is fraught with peril from the very first moment. The calf enters the world with a dramatic 2-meter drop to the ground, a startling introduction that serves to sever the umbilical cord and shock its respiratory system into action. Although it can stand and even run within an hour of birth, it is small, clumsy, and incredibly vulnerable. For the first few weeks of its life, a baby giraffe is a prime target for a wide range of predators. Lions, hyenas, leopards, and African wild dogs all see the young calf as a relatively easy meal, a stark contrast to the immense challenge of tackling a fully grown adult. To counter this constant threat, giraffe mothers have developed a dedicated and protective maternal strategy. For the first few weeks, the mother will keep her calf hidden in a secluded patch of tall grass or thick bush. She will stay close, nursing her young and standing guard, only leaving for short periods to feed and drink. During these crucial early days, her vigilance is the calf's only real protection against the many dangers lurking on the savanna. The mother's bond with her calf is strong, and she will aggressively defend it against any predator that dares to approach, using her powerful kicks to drive them away. As the calves grow stronger and more mobile, their mothers lead them to join a creche or nursery group. This is a collective of several mothers and their young, a strategy that offers safety in numbers. While some of the mothers go off to feed, one or two will remain behind, acting as sentinels for the entire group of calves. This cooperative babysitting arrangement increases the chances of spotting an approaching predator and allows for a more effective group defense. The presence of multiple large adults makes it much more difficult for a predator to isolate and attack a single calf, significantly improving the odds of survival for the young giraffes. Despite these protective measures, the mortality rate for young giraffes is tragically high. It is estimated that less than half of all giraffe calves survive their first year. This harsh reality exerts immense selective pressure, ensuring that only the strongest, fastest, and perhaps luckiest individuals live long enough to reach adulthood and pass on their genes. This perilous start to life underscores the brutal efficiency of the natural world. Survival is a daily struggle, and for a young giraffe, every sunrise marks another victory in its long journey towards towering maturity and relative safety from the predators below. The African savanna is home to giants, giraffes, elephants, and rhinos, peacefully sharing space. Each species has its own feeding style. Giraffes browse treetops, elephants feed on many plants, and rhinos graze below. This niche partitioning lets them coexist with little competition. Together they form a stable, complex community, Africa's gentle giants living side by side. In the African savanna, the giraffe's height and sharp eyesight make it a natural watchtower. Other animals like zebras and wildebeest watch giraffes for signs of danger. When a giraffe becomes alert, the whole herd reacts, gaining precious time to escape. The giraffe's silent vigilance helps keep the entire community safe. Once, the giraffid family was a diverse group. Giants like Civatherium and Giraffoconyx roamed ancient Africa and Eurasia. Today, only the modern giraffe remains, the last of the high reachers. Its towering neck and unique adaptations let it thrive where others vanished. The giraffe stands as a living monument to a vanished world of giants. While the giraffe stands as the last of the high reachers, it is not entirely alone. Deep in the Congo rainforest lives the okapi, the giraffe's only surviving relative. With its velvet coat and white stripes, the okapi is perfectly camouflaged for the shadows. Look closer, and you'll see the shared heritage: ossicones, a long tongue, and a unique gait. The okapi is a living fossil, a window into the giraffe family's ancient forest past. Both giraffe and okapi survived by following different paths, one to the open savanna, the other to the deep forest. The giraffe is a masterclass in specialization. Its height lets it reach leaves no other animal can. But this unique advantage is also a risk. If its habitat changes, the giraffe cannot easily adapt. Its greatest strength may yet become its greatest weakness. Evolution's double-edged sword. The grand evolutionary saga of the giraffe, which has unfolded over millions of years, has now entered a new and perilous chapter, one defined not by natural climate change or competition, but by the overwhelming influence of a single species, Homo sapiens. In the last century, giraffe populations across Africa have plummeted by an alarming degree. The silent giants are quietly disappearing. They face a torrent of modern threats that their evolutionary history has not prepared them for. The primary threats are habitat loss and fragmentation. Human populations are expanding, converting savannas into farmland, settlements, and infrastructure, shrinking and chopping up the vast open spaces that giraffes need to survive. This loss of habitat is compounded by other dangers. Poaching, both for meat and for other body parts, continues to be a serious threat in many parts of the continent. Civil unrest and conflict in some regions have also taken a heavy toll on wildlife populations, including giraffes. Even the construction of roads and fences, which may seem harmless, can fragment populations, preventing them from accessing vital food and water resources, and isolating them into smaller, less genetically viable groups. The world is changing faster than the giraffe can adapt. The slow, patient process of natural selection cannot keep pace with the rapid, sweeping changes being wrought by humanity. Conservationists are now in a race against time to secure a future for nature's tallest marvel. Efforts are underway across Africa to protect critical giraffe habitats, establish wildlife corridors to connect fragmented populations, and combat poaching through enhanced law enforcement and community engagement. Scientists are using GPS tracking and genetic analysis to better understand the needs of different giraffe subspecies and to develop more effective conservation strategies. These efforts are a testament to our growing awareness that the survival of this iconic species is our responsibility. The next chapter in the giraffe story will be written not by natural selection, but by human action or inaction. The giraffe stands today as a symbol of both the incredible power of evolution and the fragility of life in our modern world. Its journey from a small, forest-dwelling ancestor to the towering giant of the savannah is one of nature's most epic tales. It is a story of adaptation, survival, and the beautiful, intricate dance between an organism and its environment. But its status as an evolutionary endpoint, a highly specialized survivor, now places it at a crossroads. Whether this magnificent creature continues to grace the African plains or fades into memory like Civatherium will be the ultimate test of our ability to coexist with the incredible biodiversity of our planet. The giraffe story is a tapestry woven over millions of years, beginning with ancient deer-like ancestors and branching into a spectacular array of forms. From four-horned Giraffes to the colossal Civatherium, evolution experimented with many paths. Sexual selection and natural selection worked together, driving the giraffe's neck skyward. Today's giraffe is a living testament to the intricate, interconnected power of evolution. The giraffe story is written in both bone and behavior. Its long neck, unique gait, and social rituals are echoes of ancient evolutionary choices. Every movement, from feeding among thorns to splaying its legs to drink, reveals adaptations shaped by survival. The giraffe stands as a living archive, reminding us that every animal is a product of its remarkable evolutionary journey. The modern giraffe, Giraffa camelopardalis, stands as a magnificent but lonely figure on the evolutionary stage. It is, along with its shy cousin the okapi, one of the last two survivors of the once thriving and diverse Giraffidae family. The extinction of mighty creatures like Civatherium and the many other transitional forms demonstrates a crucial evolutionary principle. Specialization is a gamble. While the giraffe's extreme adaptation for high browsing allowed it to conquer a unique niche and outcompete its rivals, it also locked it into a very specific way of life. It has climbed to the top of a very tall and narrow evolutionary peak, a position that is glorious but also precarious. This status as an evolutionary endpoint carries with it a profound vulnerability. The giraffe's success is intrinsically tied to the health and stability of the African savanna ecosystem. It is dependent on the presence of tall acacia trees, vast open spaces for roaming, and a climate that can support this specific habitat. Unlike a generalist species that can adapt to a wide variety of environments, the giraffe's options are limited. Its physiology, its diet, and its behavior are all so finely tuned to one particular ecological context that it cannot easily pivot if that context changes. It is a masterpiece crafted for a specific gallery, and if the gallery closes, the masterpiece has nowhere else to go. The okapi provides a fascinating contrast and helps to complete the story. By remaining in the stable refuge of the Congo rainforest, it preserved the ancestral body plan, a snapshot of the giraffid family's distant past. The giraffe and the okapi represent the two extremes that survived the great environmental filter of climate change, the radical innovator and the steadfast traditionalist. All the species in between, the ones that were moderately tall or occupied intermediate habitats, were unable to compete and eventually disappeared. The survival of just these two distant relatives highlights the immense selective pressures that pruned the giraffid family tree down to its last two branches. Today, the primary force of change is no longer a slow natural shift in climate, but the rapid and pervasive impact of human activity. Habitat loss, poaching, and human-wildlife conflict are the new selective pressures, and they are acting on a timescale that is far too fast for a slow-breeding animal like the giraffe to adapt to through evolution. Its long evolutionary journey has brought it to this critical juncture, where its past success as a specialist now makes it exceptionally fragile in the face of an unprecedentedly rapid global change. The last of the high reachers now faces its greatest challenge yet. The giraffe, an icon of Africa, stands as a gentle sentinel over the savanna. Its silent grace and towering presence remind us of nature's wonder and our responsibility. As their world changes, their future rests in our hands. Protecting giraffes means preserving the wild's beauty for generations to come. Let us ensure this living marvel continues its quiet, watchful vigil.